In this exercise, what we are going to do is to create model using key point and line, our old method, and meshing it properly to get a specific result, that is to find the reflection of midpoint of section 1. The exercise is similar to the old one. We have got a two sections of 2 into 2 centimeter and 5 into 5 centimeter, 50 centimeter length and 25 centimeter length. Loads are similar to the previous exercise and Young's modulus is also same. Let us create this problem. Analysis is structural analysis, element type add, and let us take beam element again. Okay, close. Material property, material, structural, linear, elastic, isotropic, 1.5 E7. Poisson ratios, let us take 0.3. Now we will create section, beam section, common section, rectangular section. First section is 2 by 2, apply, and second section is 5 by 5. Okay. Now we will model it using key point. In active coordinate system, first key point is 0, 0, 0. Second key point is 50, axis 50, axis 50, 0, 0. Apply. Third key point is 75, 0, 0. Okay. Now we will create line from this key point, line, straight line. Okay. Now we will mesh it. Now to mesh this, we have to mesh both the line differently. This section is 2 by 2 section and this section is 5 by 5 section. So we will have to define mesh attributes. So we have to pick each line and define its attribute. Picked line, this line is picked. Okay. And attribute for this is section, element section is 1. Okay. Now we will pick this line. Its element section is 2. Okay. So we have got different section for different line. Mesh attribute is finished. Now we will open mesh tool. Now in the problem what we have to find out that mid displacement of mid node of this bar. So we will break this bar into such in such a fashion that we will get a node in between. So we will use size control, set this line. Okay. Now we will break it. Let us break it in number of division. Let us break it in 4 parts so that we can get 2 part here and 2 part here. We will get a midpoint. Okay. Similarly, we will break line this into, now this is not important. We don't have to find any result here, but we will break it in 4 part only. Okay. This toolbar is hidden behind. We can raise the hidden item from here. Close. Now we will mesh it. Mesh. Pick all. Line is meshed. Let us see the nodes. Nodes. We have got nodes here. We want to find out the displacement of this node. Plot control, numbering, node number. Okay. Now we will have to find out the displacement of fourth node. Style, size and shape on. Okay. Plot elements. So this is our model. Nodes. Now we will apply loads. Define load, setting. Define load, apply structural displacement on node. Okay. This node is fixed in the wall. Okay. All degree of freedom is restricted. Done. Now we have to apply force 1e7 and 2e7. Force on node. This load is in x direction, fx 1e7. Okay. On node this 2e7. So our modeling of our problem is complete. Now we will solve it. Solution is done. So this is our solved problem. Now we will find out list result, nodal solution, degree of freedom solution, x component of displacement. Okay. So what we were asked to find out the displacement of node 4. This value is 12.5. So we have completed our mission. This is all.